in this first one, I've got the cube root of 3 times the cube root of 4. Now, we looked at in the last lesson that we can write this, since they're both the cube root and we're multiplying them, we can do the cube root of 3 times 4, right? Put them together, and then that would be the cube root of 12. But what if the index numbers don't match? So like this next example, I've got the cube root of 5 times the square root of 5. Well, we learned in the previous lesson that the cube root of 5, if I put a little 1 right there, can be written as 5 to the 1/3, and that the square root of 5 can be written as 5 to the 1/2. But now at this point, I'm stuck. So what we're going to look at is a property that will allow us to multiply these powers as long as the base is the same. So it's called the product of powers property. And what this property says is that if you have the same base and you are raising that base to different exponents, or even if they're the same number, even if m and n are the same number, then in order to get your product, you just add the exponents together. So we're going to try that. Now, in order to try it, we've got to convert these from radical form to exponential form first. So the first factor here, the 7th root of x cubed, would be written as x to the 3/7 power. And the second one, remember, when we don't have an exponent inside, we just put a 1. When we don't have an index number outside, that means it's a 2. We would get x to the 1/2. Now, if you're not sure how to switch back and forth between radical form and exponential form, then you can review the previous video for all of that. So now we know that if we have x to the 3/7 times x to the 1/2, that our bases are the same, so we just have to add our exponents. So I'm going to do that over here off to the side. I'm going to have 3/7 plus 1/2. We need a common denominator, so go ahead and think about what that common denominator would be for a moment. And now we need our numerators. So think about what those would be. I know that 7 times 2 will get me 14, so I need to multiply by 2 up here. And then on the bottom, 2 times 7 is 14, so 1 times 7 will give me 7. So when I add them together, I get 13/14. So this would be x to the 13/14. And it doesn't say, actually there are no instructions. If I needed to have this in radical form, I could easily switch it back to that form. That just means I would kick the bottom out, and 14 would become my index number, and 13 would become my exponent inside. So it just depends, and you have to be very careful with the directions, because they will always tell you whether they want you to write it exponentially or in radical form. All right, let's try the next one. For the next one, I'm going to do the same thing. I'm going to rewrite them exponentially so that I can use my product of powers property. So the first factor, the 5th root of x squared, is going to become x to the 2/5. And then the second one, I've got the 10th root of x, will become x to the 1/10. Again, I have to add my fractions together, so I'm going to come over here to the side. 2/5 and 1/10. My common denominator, and then rewrite my fractions, and then add. Now, 5/10 can be simplified. So I could write x to the 5/10, but that would mean the same thing as x to the 1/2. And if I'm writing this in radical form, which again, the directions will always state which form you should be writing it in, if I needed to write this in radical form, it would just be the square root of x.